Hi, welcome to Send to Print. In this video, we're going to show you how to model a threaded bottle using the Coil tool in Fusion 360. First, let's take a look at these everyday plastic bottles. Notice the threading here. It has a wide pitch and very few turns. Same with this one, and it's more obvious on this one, right? These real-world bottles are quite different from the ones we created using the thread tool in our last video. Here's why. Plastic bottles are designed for manual twisting, usually opening in just a turn or two. We want some tactile feedback without the parts seizing up, and they need to account for plastic deformation and wear. That's why these threads share a few key features: a large pitch and a low thread count. Screws, on the other hand, serve a different purpose. They're for locking and resisting loosening. They have a tight pitch and many turns to maximize the friction surface, which is exactly what the thread command we used before is designed for. So today we'll use the Coil tool to model a bottle that's much closer to a real one. It only takes 15 steps in Fusion 360. Perfect for beginners. First, let's check the dimensions. I've designed this bottle to be quite small for a quick test print. We'll enter these values into the parameters in Fusion 360 so we can easily adjust them later. Click Change Parameters under the Modify panel. First, set the bottle diameter, bottle D, to 50 millimeters. Next, the bottle height, bottle H, to 40 millimeters. Finally, the thread area height, name it thread, to 10. To better manage our resources, let's start by right-clicking the root directory in the browser and click New Component. Name it Bottle. Next, click Create Sketch under the Create panel and pick the XY plane. Press C on your keyboard for the circle tool, draw it from the origin, and enter Bottle D. Then, press E to extrude, set the height to bottle H, and we have our solid bottle body. Let's rename it to Bottle. Press E again, select the top face, and set the direction to two sides. Enter 1.5 millimeters for the cap thickness. And for the downward direction, enter thread for the thread area. Set operation to new body. Rename this new body to cap. Now we have a solid cap. Let's hide the bottle body. Click the shell tool under the Modify panel and select the bottom of the cap. Enter 1.5 millimeters and the basic cap is done. Now, let's turn the bottle back on and deal with the bottle. Select the Combine tool under the Modify panel, select the bottle as the target body and the cap as the tool body. Set the operation to cut, and make sure to check Keep Tools, as we don't want to lose the cap. For a better look at what's happening inside, we're adding a section analysis under the Inspect panel. Pick a side view, and click OK. Before we move on, let's take a look at the fit. The gap between the body and cap is 1 millimeter. Since our thread section diameter is 1.6 millimeters, which is a 0.8 millimeter radius, there's a 0.2 millimeter clearance between the thread and the bottle surface. Now, back to the modeling. Use the Offset Face tool under the Modify panel, select the outer neck surface, and offset it inward by 1 millimeter. This will create the gap. Next, under the Modify panel, use Shell tool, click the top of the bottle. Let's give it a 1.5 millimeter thickness. We can see an overhang here, so let's fix it with the chamfer tool under the Modify panel. Select the edge and enter 2.5 millimeters. It doesn't have overhang issue anymore, but it looks a bit thin here. We'll leave it and fix it later. While we're at it, let's also add a 1 millimeter chamfer to the bottom of both the cap and the bottle, so we won't have elephant foot during 3D printing. Back to the neck. To thicken it, use Offset Face again and offset it inward by 1.5 millimeters. Much better now. Okay, that's 9 steps down for the basic structure. Now, let's move to the most important part of this video, modeling the threads with the Coil tool. Hide the cap for now. Use the Coil tool under the Create panel. Select the bottom face of the thread area, align it with the center, and set the diameter to the outer neck, which is 45 millimeters. In the final version, I updated the input here to bottle D minus 2 times the cap thickness of 1.5 millimeters, then minus 1 millimeter clearance on each side. This allows us to use parameters to easily modify the bottle dimensions later on. Set the section to circular with the 1.6 millimeter diameter we talked about earlier. Set the revolutions to 1.5, which is a turn and a half, and the height to thread -2. We're leaving that 2 millimeter gap to ensure the cap can tighten fully with a bit of redundancy. Make sure to select new body so we can modify the hard ends later. We can see the ends of the coil are a bit too sharp, so let's smooth them out for an easier slide in. Click the sweep tool under the Create panel. Select the circular end face. Set the distance in this direction to 0 and the path distance to 0.1. If it's not enough, you can increase it later. Set the taper angle to -10 degrees to narrow it down. Set the operation to join. Make sure the bottle body is hidden for now so they don't merge yet. Once confirmed, we have a smooth lead-in. Repeat this for the other end. Before confirming, turn the bottle back on. Now click OK to join them all together. Okay, the thread of the bottle is completely done. Now let's hide the bottle and do the same for the inside of the cap. Use Coil again. Select the inner top face, align with the center, and set the diameter to the inner cap surface, which is 47 millimeters. In the final version, I updated the input here to bottle D minus 2 times the cap thickness of 1.5 millimeters. Use the same 1.6 millimeter section, 1.5 revolutions, and thread -2 for height. Use the sweep tool again to smooth out both ends. And we're done. Look at the timeline. We have now completed the modeling in 15 steps. Even though it looks like there is a big gap between the threads and the cross section, it won't affect the print or the fit. You can press M for the Move tool, select the cap, choose Rotate, and use the top circular edge as your axis. Turn it to the proper angle so the big gap or overlap disappears. This model and the Fusion 360F 3D source file are available on MakerWorld. You are welcome to download and check the source file. Through this file, you can clearly see every step of the modeling and the parameters I've used. And through the parameters table under the Modify panel, you can easily modify these parameters and customize the dimensions. Okay, send to print. After half an hour of printing, you can see the threads turned out perfectly. Smooth rotation, and a nice, tight fit. This is much smoother than the standard thread tool we used last time, which can be quite stiff, especially on the first twist. Now we have a bottle that's much closer to a real one. Which tool do you prefer, Coil or the standard thread? Or maybe you have a better solution. Let me know in the comments. If you found this video helpful, don't forget to like, subscribe, and share your thoughts in the comments. See you in the next one.